Welcome back, and in this video we're going to be looking at implicit and explicit casting in Java, which is basically when you take an object of one type and you convert it into another. And so this can actually be quite useful when we want to cut down the number of lines of code that we want to write, which is always important for a programmer. So for example, say I had a function which only took in ints, and I wanted to use it with a double. Well then, what I could do is simply use casting to change the type. So let's get straight into it. And as you can see, I've defined a variable num, which is equal to 4, and then I've simply printed it out. And so if I run that, we can see I get a 4. So let's look at how we would change this to a double. Well, it's actually not too bad. So what I'll do is define the double, and I'm going to call it cast to double, because it's going to be an int that's being cast to a double. And what I actually do is simply just put a pair of brackets with the data type that I want to cast to in between them. And then I throw in what I want to cast. So in this case, num. And so if we actually print this out, then we can see that, well, when I printed out num, I got a 4. But when I print out cast to double, I get 4.0. So this makes sense because a double is a decimal number, so having a 0.0 is logical. But what if I wanted to do this the other way around? So say I had a double, and I'm just going to call it new num, and that was equal to 4.6. Then if I was to print that out, well, I'm not going to bother running it just yet, because we knew we would get 4.6. And so let's look at how we would convert it back, or cast it back to an int. And so I'm going to call it int, and then cast to int. And I'm going to follow the same procedure as before, and explicitly cast with the int data type in the brackets, and then put in new num. And then if I print that out, well, what I'm actually going to do is, for now I'm going to say 4.2, and we'll see why later. And so if I run that, well, we get a 4.2, which refers to this new num being printed out, and then a 4. And so from that, we can actually see that the new num has been rounded to be able to fit into an integer or a whole number. And again, that makes sense because int's a whole number. So if we do 4.8, well, that should round to 5, right? So let's have a look at that. And as you can see, no, we actually get 4.8 and then we get a 4. And that's because, and this is a really important thing to note when you're casting, Java doesn't actually round your numbers. What it does is simply just cuts everything past the decimal point. So you could have anything past here, but it's only going to take this value here, or everything before the decimal point. Now, let's look at what happens when I convert an int to a byte, say. So what I'm going to take is, I'm going to have my int, and let's say we look at the age of a tortoise, and say it was 96, for example. Then we do the same thing, so byte, and then convert to byte, and obviously the name is whatever you want it to be, but I'm just doing this to make it simple. And then I put in my byte in between my brackets, and tortoise age. And so if I was to print out convert to byte, then we would get 96. And so I'm just going to comment this stuff out so it makes it a lot clearer. But as you can see at the bottom, we get our 96. What happens if, so for example, we can have tortoises living up to, say, 150. So say I had one that was 146. Well, if we run this, we can see we actually get minus 110. So it looks like something's gone kind of wrong here. And the reason for that is, if you remember in my earlier videos where we were going over the different data types, we looked at a byte, and we saw that the values in a byte could only actually range from minus 128 to 127. And so essentially, if you go over this, we sort of get a bit of a wild number thrown out here. And so along with rounding, that's actually another thing we also need to be wary of. But that essentially gives an overview of what explicit casting is. And so now we're going to move on to implicit casting, which is when Java sort of helps us out and kind of does the casting for us. So let's have a look at what I actually mean by that. And what we're going to do is define a new int called num1, and I'm just going to make that equal to, say, 2. And then a new double called num2, which is going to be equal to 2.4. And so if we were to add them both up, well, we both know that 2 plus 2.4 is 4.4. However, what we're actually doing is we're adding two objects of different types. And so if we run that, we can see we actually get the answer 4.4 as opposed to, say, an error. And that's because Java's essentially taking this int and the double and casting them so they're of the same type. And that allows us to perform our calculations with a lot more ease. So you can sort of imagine it as throwing in those brackets, similar to that ones we had here, in the background. And it's also really important to note that when you're casting, you have to make sure you use a bit of, well, common sense. And so, for example, you can't exactly cast a number to, for example, a Boolean. So if I define a Boolean test, and I tried saying Boolean num1, then I'm just going to get yelled at by Java saying, or by IntelliJ saying you can't cast an int to a Boolean. However, what would we do if we say wanted to try a string? Would that work? Because there's logic for either side. So for example, we could have the number printed but just as a word. Similarly to how we would write the number 4 in words. So let's go ahead and try that out and see what happens when we say string test is equal to num1. And as we can see, we actually get an error. And it's slightly different to the last one because it says required java.lang.string, but it's found an int. And if we remember, a string is actually of type object. And so being an object, it's defined in a class as we looked at in the last video. And it also has its own library functions, which we can use. So what we would actually say is string dot value of num1. And what that will do is simply convert it into a string. And so that's an example of actually converting a data type into an object. And we can actually do this the other way around. And so we could say int back to int. And what we'll notice is each of these primitive data types actually have an object of the same type. So for example, int has an integer class which has its own set of methods and functions that we can also use. And the same goes for double. So for example, I can say int then integer dot to see all the different functions available in the integer class. And then I'm going to choose value of string. And then if I just simply put in test, what it will do is I can actually print out system.out.println back to int, and I will get my test value num1 printed back out. And so here's an example of where we then take an object and convert it into a data type. And these are available for all the classes. So for example, I could say double, and then if I change this to double.value of test, then we can actually see that if I run this, 2.0. And so that's an introduction to how each of the data types actually have their own corresponding object class. And I would definitely recommend looking at these and checking them out and playing around with them. Otherwise, I hope you found my content useful, and as per usual, I'll post all this code in my Git repository, which will be posted in the link in the description below. Other than that, please check out my channel for more Java videos, and please do like, share, and subscribe.